Okay, so today we are doing 3.4, okay, and not so bad. Okay, so 3.4, it's not on page 45, sorry, we forgot to change these numbers, so we are not on page 35. But before we do that, let's write down your homework. Okay, your homework is, purple, let's do purple next. Your homework is 0326. Your homework is additional practice section, additional practice, and AFQ for 3.4. We're doing page 70 and 91. Do 0328. Okay. Pause it if you need to. I'm going to move on. All right. So you have a quiz next class. It's not a surprise. Stop your groaning. Okay, quiz 2. Again, out of 20 points. Here are the topics. Okay, I'm going to go to page 100 because there is some scratch paper there. So this is page 100 right down here. Okay, and I'm going to list the skills that you're going to be needing for that is going to be on your quiz. Okay, so these are the skills that will be on your quiz for next class. You have to find the circumference when given the diameter. So you find the circumference given the diameter, okay? And that's on page 33 if you want to see the notes for that, okay? Find the area of a circle. So you have to have an equation for area of a circle if you have the diameter. We've been using radius, so you need to know how radius and diameter interact with each other, okay? Find the area of a circle given its radius. Okay, that's also on page 37. Just like diameter, it's just that the radius is in our formula. Here, finding the diameter given the circumference. That's on page 33. The equation, this equation for this one has to equal diameter. Okay, that's the equation you're looking for on page 33. And find the area of a circle and a square, and then compare their areas. So you're going to be given descriptions of these questions on your quiz. There are no drawings. You're going to have to be able to create the drawings if those are helpful for you. Okay, there are no drawings on your quiz. Okay, again, pause if you need to. I'll try and copy these to all the classes. I know this is period 6's notebook that I'm writing in, so will be updated in theirs for sure. I'll try and remember to put in all the other ones as well. All right, moving on. We're going to go to page, I believe it's page 35. No, 35, I think. Let's see. Circles here. All right, so 3.4. Today is 032619, and we are on page 35. Okay, what is the relationship between area and the circumference of a circle? So we got to find the relationship of those two items. Okay. So here is my circle, which is in the form of a pizza. Okay, this is my circle, and this shape here is that's right, it's a parallelogram. Okay, there's my parallelogram. This side is parallel to this side. So I'm going to list this one as a parallelogram. Now I put these in quotations because it doesn't really look like a parallelogram because it's got like these edges which are a little bit rounded. Okay, so what you'll notice is that this parallelogram is made up of 1, 2, 3, 4, 5, 6, 7, 8 slices of the pizza, and this pizza is made up of 1, 2, 3, 4, 5, 6, 7, 8 slices as well. That means that the area of the circle or the pizza is the same as the area of the parallelogram. Okay, So how are this circle and parallelogram related? Okay, first, they have the same area. Same area. We know that because they have the same number of slices. Okay, the slices are equivalent. 8 slices in one, 8 slices in the other. Now, what I notice is that if we're talking about area, what is the equation of the area of a parallelogram? It's not so bad. This one is the base. Some people call it the length. Okay, the distance from here to there times the height. I'll do this in a different color. Times the height, how tall it is here. Okay, now the height is unique because this height here, when you notice I put it right over the parallelogram, the height is the same as the radius of the circle. Okay, the height of my parallelogram is the same as the radius of the circle. Okay, so I can say that the radius is equal to the height of parallelogram. Height of parallelogram. Okay, they have the same area, their height and the radiuses are the same. Now let's look at the base part, this green portion here. I'm going to use a darker green. I've got 1, 2, 3, 4 edges of the pizza, okay, that make up that base. Now if I go 1, 2, 3, 4, what can I say about the base of the parallelogram compared to the circle? I can say that, is this the distance around here? It's called my circumference, but it's not the whole circumference. It's only 4 of the 8 parts, which means half of the circumference is equal to the base of the parallelogram. Okay, now parallelograms include squares and rectangles as well, so just a reminder. Okay, so we've got an equation that says the radius is the same as parallelogram, half the circumference is the same as the base. This one should be equal to base times height, and I can switch those out with radius. This one is the same thing as radius times the base, or instead of the base we can say half the circumference. 1/2 circumference. I'll just put a circ, so fit. So that's our equation. It should end up to be pi r squared. I'm gonna play a video for you guys so you can see what it looks like. Area of a circle. Okay, hold on. It's not seeming to play. So let's see.
First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts.
Let's see if I can get it without the airplay. Just a second. All right, so we got to figure it out. Here we go.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle.
Okay, so that's kind of what we had in class, in our notebook, where we had a circle cut into 8 parts, and it looks like a parallelogram, not really like a rectangle, but you kind of get the general idea.
So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it...
Okay, what you notice is, this looks a lot more like a rectangle than this one does. What he did is he cut into smaller pieces.
It appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius, so height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle.
Mind blown.
So pi r squared can be used to calculate the area of any size circle that exists.
Alright, so what that means is, let's go back to our book. So we derived pi r squared. So we've just derived the formula for area of a circle. Looks like this. Okay. Your homework is a combination of two things. On page 92 first, we'll look like this. Okay. It asks you for a couple of things. It tells you that we are looking for the circumference and the area, and they say use 3.14 for pi. So what I did here at the top was I wrote the equations for circumference and area, because those are the two things we're going to be doing. Now I wrote two versions of the equation, one with diameter and one with radius. And then for area, I wrote one with radius squared and one with r times r. You can use either one, okay? They are the same equation. And a couple of notes here, if you get diameter, you can turn it into radius by dividing it by 2. If they give you a radius and you need the diameter, you can multiply by 2 and you get your diameter. Okay. Show your work on this page. If you come up with a riddle and no work, I'm not going to give you credit. So show the work, okay? Show the work. All you have to do is write down what you did. For example, here what we did is we did pi times diameter. We did 3.14 times a diameter of 6 equals the circumference. I just wanted to see this. You do not have to do it longhand. Just write down what you type into your calculator. For area, same thing. Write down what you type into your calculator. Okay. Erase all this. This is just my notes. Okay. All right. This is your first page of your homework. Page 70 looks a little bit like this. It's asking you to find the area of the shaded region. You find the area of the rectangle first, then you find the area of the circle, you add them together. We've done something like this as well on previous pages on page 68. And area of the shaded region here, find the square, and then subtract the circle. Okay, you'll find something similar, kind of similar to this, but a little bit easier on your quiz, okay, of comparing areas. Okay. Again, this will be posted on Google Classroom, so you guys can see it there as well if you need to play it over again.